Hello everyone. Do you have a Raspberry Pi and want to run applications with Docker? In this video, I'll show you how to install Docker, Docker Compose, and Portainer. This is a production-ready, easy-to-use, and scalable solution to manage everything on your Pi. First, connect to your Raspberry Pi via SSH. Next, we need to update the system's package repositories to ensure all software packages are up to date. Next, we'll install some essential tools to support the upcoming Docker and Portainer installation. Next, we'll install Docker using an official script directly from Docker. This method ensures a quick and reliable installation process. This script will automatically download and execute the necessary Docker installation steps on your system, making the deployment process straightforward and quick. Once the installation is complete, you can check the Docker version to confirm that the process was successful. As you can see, version 29 has been successfully installed on our system. After a successful installation, next let's start and enable Docker to ensure it runs immediately and automatically starts with the system boot. And you should also check Docker's status to confirm it's running normally. If you see an active status like this, it means Docker has started successfully and is ready for use. By default, when executing Docker commands, you need to use sudo for elevated privileges. This is because the Docker daemon typically runs with root permissions. And if you try to execute Docker commands without sudo, you'll see an error message similar to this, indicating insufficient permissions. To be able to run Docker commands without sudo, we need to add the current user to the Docker group. After that, you can check again using the groups command to confirm that you've been added to the Docker group. However, at this point, you won't immediately see the Docker group listed, as group changes typically only take effect after logging out equals or restarting the system. Therefore, please reboot your Raspberry Pi to apply these changes. Once it has restarted, please reconnect to your Raspberry Pi so we can check again. Now let's check again using the groups command to confirm you've been added to the Docker group. As you can see, the Docker group is now in the list. This means you can now run Docker commands without sudo. Next, I'll try running a Docker command without sudo. The command executed successfully, proving that we can now use Docker without needing root privileges. Next, we'll optimize Docker for our system. Please navigate to Docker's configuration directory. Here, let's create a new configuration file named daemon.json for Docker. Next, open the configuration file with an editor. And then add the content I've prepared here. Because we're using a Raspberry Pi, we need to optimize Docker's configuration to manage logs efficiently, helping to save system resources. By default, Docker logs continuously without limits, which can quickly fill up storage, especially on a Raspberry Pi. With this configuration, each log file will be a maximum of 10 megabytes, and only the 3 most recent files will be kept. This means each container will use roughly 30 megabytes for logs, keeping our system stable and preventing the SD card from filling up. After adding the content, please save and exit the file. Then, restart Docker for the new configuration changes to take effect. And also, let's check Docker's status to ensure everything is running correctly. If the status is active, it means Docker has successfully restarted and is operational. Alright, we've successfully installed Docker. Next, we'll proceed with installing Portainer to manage our Docker containers more intuitively and easily. Before we continue, I suggest the following application directory structure. With this structure, we'll have a centralized place to manage our Docker applications, making it easy to track and back up data for each service. Therefore, next we'll create the suggested directory structure, a main container directory, and inside it, a dedicated Portainer directory. Here, let's create a configuration file for Portainer. Next, let's open the file we just created to add the configuration content. Next, let's open the file we just created to add the configuration content. In this section, we'll configure Portainer to automatically restart in case of system issues, ensuring continuous operation. Next, we'll enable a security option to prevent containers from self-elevating privileges during operation. Here, we'll open two access ports, one for the regular web interface and a more secure one if you plan to use HTTPS. This part is crucial. We'll mount a direct connection to Docker so Portainer can manage all containers on the machine. At the same time, we'll create a dedicated data volume so all of Portainer's configurations and settings are retained, even if the container is removed. Next, we'll set the Vietnamese time zone to ensure accurate time display and logging. Finally, we'll create a dedicated network for the container, making the system more organized and easier to expand with other services later. Once the content is added, please save and exit this configuration file. Now that the configuration is ready, let's deploy Portainer. During the first execution, the system will download the necessary components, which might take a moment depending on your internet speed. If you see a result like this, it means Portainer has been successfully installed and is ready to use. You can also check the status of your running containers to confirm. You'll see a similar output to this. However, with the current display, it can be quite confusing to keep track of your containers. And this is exactly why we use Portainer, to manage them more intuitively. Now let's check your server's IP address so we can access Portainer via the web browser. This is my server's IP address. Yours might be different, so make sure you use your own address. Now, open your web browser and navigate to your server's IP address. On this first screen, please enter your desired username and create a strong password for your admin account. Next, on the Environment Setup page, let's select Get Started to proceed. Next, select the local environment. Immediately after, you'll be taken to the dashboard. From the left-hand menu, please select Containers. And here, in this container list area, you can see all the containers running on your system in an incredibly intuitive way. This is significantly more convenient than having to use the command line interface with the Docker ps command to check the status and information of each container, isn't it? So there you have it. We've successfully installed Docker and Portainer on our Raspberry Pi, ready for easy and efficient container management. Thank you for watching, and I look forward to seeing you in the next video.